So, first of all, before we go on to watching this video, I just want to let everybody know that I'm making this because I was inspired by a recent numberphile video that I just watched. That video itself is kind of old. It's like 3 or 4 years before this video came out, but I only just watched it, so it's new to me. And that video you can find either somewhere around here on the screen or maybe just there'll be a link in the description. I'm not exactly sure if it's only end screens that I can put links onto videos for, but I definitely recommend watching that video first. In this particular video, though, we're going to take that concept in the first half of that video, the Sierpinski triangle, and we're going to implement it here in CMU CS Academy's development environment. It seems like it's pretty easy to make. I'm going to put this video alongside whatever skills you need to do to be able to make this. I'm pretty sure I just looked it up. It should be somewhere Unit 7 or Unit 8 where you just learned random generating your first kind of random number, as well as loops have happened recently, which is all we would really need to be able to do this. So, all right, let's get to it. I'm going to implement a basic version of it, and then you can feel free to add on and implement it with randomized points and multiple different points, but we're just going to start with just the basics, right? So what I need are 3 points to start off. So let's get to it. I'm going to make a point A at 250 and a radius of 5. Oh, well, point A should be equal to a circle with all this information. And then we have that over there. You could randomize where these points are, but I don't want to do that right now. I'm just going to make 3 points at random spots. Point B, I'll make it a circle at, let's say, 5,300 with a radius of 5. And then point C, I'll make a circle at, 350 with a radius of 5. And here are our 3 points that we're going to be jumping between. And, right, I'm assuming you've watched the numberphile video, so you know how the Sierpinski triangle is supposed to work. We'll also need a starting point, and this one I will start at a random spot. Not that I need to. I guess I could just put it anywhere, but I'll start at a random spot. So we're going to make a circle at rand range 0 to 400, rand range 0 to 400, and it'll have a radius of 1. And there's our little starting point in this particular case, though every time I run this, my starting point is going to be in a different location. It, apparently doesn't matter where it goes. And then finally, I don't think I need a function for this. I can probably just use a for loop. So for I in range, let's start with 500. I feel like that's pretty okay. For I in range 500, what we need to do, so this is going to be like, let's kind of label this out. Oh, let's see. Let's disable the orangeness. Ooh, all right, that's a little nicer. So, I don't know if that shows up in the video. That'll be interesting to see. Oops, sorry for bumping the mic. These are starting points, and this will be generate the image. First, we have to choose a point to go between. So we're going to choose a point to go towards. And once we do that, then go halfway between this point, between most recent point and chosen point. Choose a point to go towards, then you go halfway between the most recent point and the chosen point, and then you repeat. Then repeat. Though it's looking like I'm going to have to store a recent point. I guess I can say recent point X, and I'll set it equal to starting points center X. and a recent point y, and I'll set it equal to starting points center y. And this is all just within just kind of a basic script, so I don't need to care about locality or of variables or whatnot. Okay, this should be everything that we need to be able to do it. And if not, we just make more. So let's choose a random point to go between. So I'm going to create a variable here. Yeah. Whatever. I'm going to create a variable. Sorry if it's bad to do this inside the for loop. Maybe I'll do it outside of the for loop. And then go towards equals -1. Sure. Okay, so now I'm going to say go towards is equal to a rand range between 0 and 3, which will actually generate 0, 1, or 2. And then we're going to say, okay, if go towards is equal to 0, this is going to mean go towards point A. So if go towards is equal to 0, we're then going to create a circle at the halfway range between the recent point x, recent point y, and the starting point. Now, the midpoint of a line, that's something like you add the two x's and divide by 2, and then you add the two y's and divide by 2. It should be good, right? Let's see, if I'm just thinking of x, and I'm at 5, and let me say between 4 and 10, halfway between those two. All right, let's make it easier. No, 0 and 10 is easy enough. 2 and 10, halfway between those two should be 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's 4 and 4. Wait. God, I'm so dumb. I'm pretty sure it's just going to be add the two x's and divide by 2. So we're going to make the circle's x coordinate be the recent point x. Let's do an extra parentheses, recent point x plus point A dot center x divided by 2. And then the same thing, recent point y plus point A dot center y divided by 2. And then we're going to make it a radius of 1. And even if we just try this, what I should see is just, because I don't do anything else, oh, yes, that's fine. It's not going to be an infinite loop because we're using a for. If go towards equals 0, this should just make like a bunch of points between the first point and 1. Starting points is not defined. Line 7. Oh, duh. All right, let's see. Hey, look at that. It made 3 points only. I feel like it should make like way more points. Okay, great. We discovered something. What you also need to do is we need to set the recent point x and y to that circle's x and y. I mean, I guess this is kind of dumb, but we're just going to set recent point x equal to this stuff, and recent point y, I will set it equal to this stuff, and now I'm resetting the recent points things. And now, yeah, here we're talking. We're going way in between, and we've got the who is it? Who is it, like Theseus or something that goes with the tortoise or whatever? Anyways, that's a whole other topic. Great. Looks like we got the 1 point working. And now what we're going to do is elif go towards equals 1. We're going to do the same thing except between point B. So I'm just going to copy this. All of what I'm doing is like really bad practice, you know, but all this copy and pasting, if things are wrong, it's going to mess it up. But we're just, you know, prototyping right now and trying to show you all this and make sure that we do point B. Whoops. I don't know what command B does. And then elif, yeah, I kind of like that in line there more. Elif go towards is equal to 2. Then we'll do all this, but with point C. Point C, point C. So what we're doing here, let me zoom in a little bit. I'm realizing for the first time in this video that maybe you can't even see the code that well. But we're too far into it. I'm not going to reset now. So what we're doing is going towards point A and go towards point B, and then we're also going to go towards point C. Go towards point C. And what's happening is I'm just using what I recalled was the midpoint formula and didn't do a good job because my arithmetic is horrible of proving to myself that it is the midpoint formula, but it looks like it is because it worked when we tried it. So we make a new point at the midpoint between recent point X and point A's center, and then we reset the recent point to the new X and the new Y. And depending on if we rolled from our random number, a 0, a 1, or a 2, all we're doing is instead of going between the recent point and point A, we'll go between the recent point and point B, or the recent point and point C. I think that's actually going to be it. We'll just need to up the range. I guess I should do an else just in case something else really bad happens. I can say else and just print something bad just in case. But now we should have the program creating the Sierpinski triangle. Oh my goodness, it happened. It's so spooky. Okay. Oh, maybe I should make this instead of in a loop, I should do it on mouse move so you can see it generating because it just kind of loads it all at once. But if I go to 5,000 now and we do it, it's going to take a little while to run. Oh, stack trace error. Too many shapes in your code. You created more than 2,000 shapes. Whoa. App.setMaxShapeCount n. All right, let's do it. It might cause your code to run slowly. So even at 2,000, we got, oh, that's so freaking cool. Yikes. I do see that, that we're pushing the limits here. Okay, we're going to just set the max points to 5,000. Max shape count to 5,000, I guess, and 5. And let's try this again and hope that it doesn't crash. Oh, I wonder if the video is going to show up poorly because my computer is like 8 years old here, this laptop. We'll see how the recording goes. All right, I'm going to run it again. Yikes. Ooh, a little bit darker over there. Oh, that's so freaking cool. And you can even see, like, it keeps going, right? You can see more and more triangles in between. I can't really point to it, otherwise it freaks out, but oh yeah, we did it. All right, we recreated the Sierpinski triangle. And I guess that's where I'm going to end the video for now. Maybe I will do this with an on mouse move. I did it for I in range just because a loop is the easiest way to do this. Not that it's going to change that much on mouse move, honestly. I mean, actually, though, if I just said on mouse move XY and just ran it like this, we'd have to define on mouse move and just ran it like this. Oh, and then there's the yeah, I just have to make these global. Yeah, we're not going to bother to do that. Well, all right, let's just do it. So I'm just going to make a global variable. We'll just call it whatever. I mean, I can even literally just store this on point A, which is so stupid, but we're just going to do that. Point A dot, or at least, all right, at least let's starting point. That kind of makes some semblance of sense. This is so stupid. Oh, all of this is going to get so grossly huge. Let's call it RPX, recent point X, and RPY for recent point Y. And that way, yeah, we're just going to redo all this really quickly. So this is, instead of RPX, it's going to be starting point dot RPX, starting point dot RPY, starting point dot RPX, starting point dot RPY. This is the most boring thing for people to be watching, I'm sure. Oh, actually, let's copy that to save us some time. Boom. Boom. Y. And then we're just going to recopy this code again. Actually, I guess I can go from there. And boop. Boop. And then change all of this to point B. Oh my goodness, I should just be clicking point B, point B, point B, and C, 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 C. All right, now we're cooking, because now we got it on mouse move. I don't want to go back. And oh, what? Start point is not defined. Starting point. Starting point. Yeah, this is what happens when you code sloppy. Dumb stuff happens. Oh man, you can see it generating the Sierpinski triangle as I move the mouse around. This is definitely cooler than just seeing the for loop just generated after a million times. You can really see as it's going, it's very slowly just kind of generating one point at a time. You can see this happening, following the rules that we saw in that numberphile video. Though this does happen way too quick, or way too slowly rather. Maybe what I should do, let's all right. On mouse move will generate 3 points. I don't even know, is this useful to you? If you're still watching it, I guess you find it useful. I'm just going to say for I in range 3, and then I'm sure there's a way to do this smarter, but I'm just gonna smack this a bunch of times. I'm sure there's a way to auto indent, but now this should actually go quite a bit faster because I'm having it go, well, it should go 3 times faster. Yeah, you can really see it kind of moving and forming over there as I move the mouse around. Something about seeing it generate as you go instead of just having the program run and then you see the triangle show up. I'm kind of into it. Still going a little slow for my tastes. Also, I hear my computer starting to huff and puff, like the fans are going on. So this old thing is It's definitely, I wonder if the video is even going to come out okay. But you can see as you generate more and more points, it slowly creates that shape that just kind of like exists. Anyways, I've been messing around already. This entire video I've been messing around, let's be honest. Oh, look at the lines are getting so like crisp. But so, you know, hopefully you can recreate this yourself. Maybe you have your program put different points on, you know, A, B, C. You change where they are at the start of every one. Maybe you add a fourth point and see what happens. And I don't know, maybe you can have like the colors change and see if there's, oh, I kind of want to make the colors change. I'm not gonna do that right now. This video is already like 20 minutes long. Though it would be cool to see if there's any pattern of, no, it's just gonna be random. Man. All right, anyways, I'll leave you to explore it. I'll explore on my own outside of the video. I'm sure this is boring enough already. But yeah, there's a dumb little program written very poorly for generating Sierpinski's triangle. And yeah, enjoy. Peace out.